These are the answers to Unit 2 Free Response Quiz B. These are the answers for both Question 1 and Question 2. So the first part of Question 1 says find the average rate of change of f over the interval -5 to 5, and then for how many values of x in that interval does the instantaneous rate of change equal the average rate of change? Two parts, find the average rate of change by connecting the 2 points and finding the slope between those 2 points. The first point is -5,3, the second point is 5,9. Average rate of change is the slope. Do the calculations correctly, you get 3/5. You do not have to reduce fractions, so you could leave it as 6/10. Second part of the question says how often is the instantaneous rate of change equal to that value? Instantaneous rate of change is f prime, so if you look at the second graph and estimate where 3/5 is, it looks like the instantaneous rate of change is 3/5 twice, once here and once there, so that answer is the instantaneous rate of change of 3/5 occurs twice. This question was worth 2 points. Second part of the first question, write an equation for the line tangent to the graph of f at x equals 2. Most people did this correctly, a couple silly mistakes, and a lot of people turn their answer into the wrong form. You can leave it in point slope form, but to answer this question, we need a point. So at x equals 2, we have a y value of 6, and at x equals 2, we have an instantaneous rate of change of -2. So putting those two pieces of information together, point slope form, y minus 6 equals slope -2, x minus 2. You don't have to change it to slope intercept form. You can leave it in point slope form. That was worth 1 point. If you have correct point slope form, but then turn it into slope intercept form and make a silly mistake, you won't get that single point. Third part, this was a little bit more difficult. Find the limit for this fraction and the limit for that fraction, and then find the value or give a reason why it doesn't exist. So again, the topic here is what's the difference between an average rate of change and an instantaneous rate of change? If you take the limit of an average rate of change, you get an instantaneous rate of change. So that statement here, the limit of the average rate of change is the instantaneous rate of change. You're taking 2 points and moving them closer and closer until those 2 points become a single point. So the blue question says, as you approach -1, what is the instantaneous rate of change? Well, it's hard to estimate from this graph, so you go over to the instantaneous rate of change graph, look at -1 and see a value of 4. The instantaneous rate of change exists because the limit on the f prime plot is 4. It's the same whether you approach from the left or from the right. For the second question, the limit as you approach 3, again, if you look at this, it's a little bit of a hint as to what's going to happen. As you approach 3, the limit from the right and the limit from the left are different. That limit doesn't exist. So the instantaneous rate of change doesn't exist. The limit on the f prime plot does not exist. And then the last part of the first question, let g be defined by this function. Find g prime of 4. G prime is product rule, derivative first times the second plus first times the derivative of the second. Substitute 4 in everywhere you see an x. Do a little bit of simplifying. Again, this answer is fine. If you reduce your fraction, you get this answer here. This one was worth 2 points. So that's it for the first question. Second question, going to be dealing with rates but using a table. According to the model, what is the average rate of change on the interval 45 to 90 seconds? Both of those values are numbers on the table, so the average rate of change is just the slope between those 2 points. Change in y or change in a over change in time. You can leave it as this fraction or reduce it down to here. And again, if you take this fraction and reduce it incorrectly, you lose that single point. So double check your arithmetic or leave it unreduced. Second part of the second question, write a prime of 95 as the limit of a difference quotient. Use the data in the table to approximate a prime of 95. So again, this first part was a bit of a challenge for people. The limit of a difference quotient. Again, what's happening is the limit of a difference quotient or of an average rate of change is the instantaneous rate of change. So doesn't matter which way you write it, but just find a difference quotient that approaches 95 for some t value, and t is going to approach 95. There's your limit statement. A prime of 95, if you go to the table, approximate, tells you to use the table to approximate, so the average rate of change is going to be the approximation. 95 is between 100 and 90, so we're going to find the average rate of change for these values here. A of 100 minus A of 90 over 100 minus 90. Again, 195 over 10. That simplifies down to 19.5, or you could reduce the fraction. Any of these three answers is acceptable. I forgot to mention earlier that this is a no calculator problem, so some people were getting values with decimals in them that you shouldn't be getting. Please read the directions, and if it says no calculator, don't use your calculator. Third part, what is the shortest interval during which it is guaranteed that A of t equals 400 for some time t in the interval? We've seen this a couple times now. To get a guaranteed output or a y value that doesn't appear on the table, you're probably going to be using the intermediate value theorem. Okay? Since 400 appears between 70 and 90 minutes, then the interval is 70 and 90 minutes, and that's one of the 2 points. And then the justification is the intermediate value theorem. In order to use the intermediate value theorem, you must have a continuous function. You're not told it's continuous, but you are told it's differentiable. If a function is differentiable, then it is continuous, so that takes care of that prerequisite. And then the two y values, or the two outputs, must surround the number that you're looking for. So since A of 70 is 250 and A of 90 is 405, by the intermediate value theorem, there must be a time where A of t is 400. And again, that was worth 2 points. So now the last question, which really doesn't use the table at all. There's a function f defined by this, and you're asked to find f prime of 10. Taking the derivative of this function produces that. Substituting in 10 produces this statement. Be careful, some silly mistakes with getting a common denominator, but your final answer is 64 over 27. So that's it. Those are all the answers to free response quiz B. And here's a picture of a giraffe on steroids for you to enjoy.